Imagine staring into the endless depths of space, where light takes millions of years just to reach your eyes, and every pinprick of brilliance holds secrets beyond comprehension. The universe is a vast, whispering enigma, filled with wonders that defy logic and ignite our deepest curiosities, and among its countless galaxies, one stands out as a treasure trove of cosmic oddities, NGC 262. This distant swirl of stars isn't just another speck in the cosmos, it's a gallery of the bizarre, a place where the laws of physics seem to twist into strange new shapes, leaving even seasoned astronomers in awe. What if I told you that within this single galaxy, there are objects so peculiar, so utterly unlike anything else we've discovered, that they challenge everything we thought we knew about the universe? Picture celestial bodies that glow with impossible colors, structures that stretch across unfathomable distances, and phenomena so mysterious they seem ripped from the pages of science fiction. NGC 262 doesn't just hide one or two of these anomalies, it cradles at least 30 cosmic enigmas, each with its own story, its own defiance of the ordinary, waiting to unravel before our eyes. This isn't just a journey through space, it's a voyage into the unknown, a chance to witness the universe's most bewildering creations firsthand, from ghostly remnants of ancient stars to formations that shouldn't exist. Every discovery within NGC 262 peels back another layer of the cosmos's grand mystery. And as we explore these 30 strange objects together, you'll begin to see the galaxy not as a distant collection of stars, but as a living, breathing puzzle, one that invites us to question, to wonder, and to dream. So let's dive in, because the secrets of NGC 262 are stranger than fiction, and they're about to rewrite what you thought was possible. The first enigma waiting for us in NGC 262 is something astronomers have nicknamed the Twisted Nebula, a cosmic spectacle that looks like it was ripped straight from a surrealist painting. Picture this: a vast luminous spiral stretching across light years, its glowing filaments writhing like tendrils caught in an invisible storm. Most nebulas we know form delicate, symmetrical shapes, pillars of gas sculpted by stellar winds, or the gentle remnants of dying stars. But this defies every expectation. Its structure twists and coils in ways that shouldn't be possible, as if some unseen hand reached into the fabric of space and gave it a violent tug. What makes it even stranger are the magnetic fields tangled within it. Normally, magnetic forces in space follow predictable patterns, guiding the flow of gas and dust into orderly formations. Here, though, they're chaotic, warping the nebula's structure into those eerie spirals. Some researchers think it might be the aftermath of a star that didn't just die, it imploded in a way we've never seen before. Imagine a supernova so powerful, so unstable, that it didn't just explode outward but twisted in on itself, leaving behind this mangled wreckage of magnetic energy and ionized gas. Others speculate it could be the result of two dead stars colliding, their combined forces creating this bizarre, swirling monument. And then there's the color. Most nebulas glow in familiar hues: reds from hydrogen, blues from oxygen, but the Twisted Nebula, it pulses with unnatural shades, streaks of violet and eerie gold that don't match any known elemental emissions. It's as if the very laws of physics bend just a little differently here, leaving astronomers scrambling for explanations. Could it be an unknown type of stellar remnant, a glimpse into exotic matter we've yet to understand? Every time we point our telescopes at it, the Twisted Nebula seems to mock our attempts at categorization, whispering that the universe still holds mysteries we're only beginning to fathom. Deep within the swirling arms of NGC 262 lurks something even more elusive than the Twisted Nebula, a ghostly gathering of stars that refuses to be seen. Astronomers call it the Phantom Cluster, not because it's made of spirits, but because light itself seems to avoid it. This isn't some empty patch of space, it's a dense knot of stars bound together by gravity, yet it emits almost no detectable light. If not for a cosmic trick of perspective, we might never have known it existed at all. The discovery came when telescopes noticed something bizarre: background galaxies warping and stretching like reflections in a funhouse mirror. That distortion, known as gravitational lensing, revealed an invisible hand bending the fabric of space-time. But here's the twist: when researchers turned their instruments toward the source of the distortion, they found nothing. No glowing stars, no radiant gas clouds, just a void where light should have been. The only explanation: a cluster so packed with dark matter that it outweighs its visible stars by a staggering margin, acting like a cosmic lens made of shadows. Dark matter isn't exactly rare, but the phantom cluster takes its dominance to extremes. In most galaxies, dark matter outnumbers ordinary matter by about 5 to 1. Here that ratio skyrockets, leaving scientists baffled. Where did all this dark matter come from? How did it clump together so densely without dragging more stars along with it? Some theories suggest this could be a relic from the universe's earliest days, a frozen snapshot of a time when dark matter ruled unchallenged. Others wonder if we're seeing the aftermath of a cataclysmic collision, a cosmic wreck where dark matter survived, but ordinary stars were flung into the void. What makes the phantom cluster truly unsettling, though, is what it implies about the rest of the cosmos. If structures like this can exist, hidden in plain sight, how many others are out there, invisible to our telescopes? It's a humbling reminder that even in an age of advanced astronomy, the universe still holds cards close to its chest. Every time we think we've mapped the darkness, discoveries like this whisper back, "There's so much more you're not seeing." Now let's turn our attention to two objects in NGC 262 that play tricks with gravity itself, objects so perplexing they've left astronomers questioning their very nature. First up is the binary black hole mirage, a cosmic illusion that challenges how we perceive reality in the depths of space. At first glance, telescopes detected what appeared to be twin black holes orbiting each other, their gravitational pull distorting the light around them in a dizzying dance. But something didn't add up. The math suggested these black holes should have merged eons ago, yet here they were, locked in an impossible stalemate. The truth: it might not be a binary system at all. Instead, this could be a single black hole warping spacetime so severely that light bends around it in a loop, creating a duplicate image, a gravitational hall of mirrors. Imagine holding a broken shard of glass up to a candle flame and seeing two flames where there's only one. That's the kind of illusion we're dealing with, but on a scale spanning light years. Some researchers even speculate this could be evidence of a naked singularity, a black hole so twisted by extreme physics that its event horizon, the point of no return, has vanished, leaving its chaotic core exposed to the universe. Not far from this gravitational enigma lies something even more baffling: the echoing void. Unlike the eerie silence of the phantom cluster, this region of space does emit signals, but they arrive late. Radio waves pulse out in erratic bursts, then repeat minutes or even hours afterward as if bouncing off invisible walls. It's like shouting into a canyon and hearing your voice return, except there's no canyon. Just empty space. What could cause such a delay? One theory points to gravitational time dilation, where the void sits in a pocket of spacetime so warped that signals literally slow down as they climb out. Another suggests the presence of exotic matter, particles with negative mass that bend radiation in ways we can't yet model. But the most unsettling idea: that these echoes aren't reflections at all, they could be messages, distortions from a parallel universe brushing against our own, leaving faint fingerprints in the static. Together, these objects paint a picture of NGC 262 as a realm where gravity doesn't just pull, it lies, toys with light, and whispers secrets we're only beginning to decode. Whether mirages or echoes, they remind us that the universe's rulebook is far from complete. The chromatic storm is one of those cosmic spectacles that makes you question whether you're seeing reality or some hallucination painted across the void. Unlike any ordinary nebula, this vast churning cloud doesn't settle into predictable blues or reds. It flickers like a malfunctioning neon sign, cycling through impossible shades of emerald, crimson, and even ultraviolet, a color human eyes can't perceive but our telescopes detect as a haunting shimmer. It's as if someone took a rainbow and shattered it into fragments, then tossed them into a cosmic blender set to turbulence. What's fueling this riot of color? For starters, the storm's core is a graveyard of dead stars. When massive stars reach the end of their lives, they don't fade quietly, they explode, scattering heavy elements like titanium, gold, and even rare earth metals across space. Normally, these elements cool and settle into stable formations, but here they're caught in a relentless tempest of high-energy particles, likely from a nearby magnetar, a neutron star with a magnetic field so intense it warps atoms into unrecognizable shapes. Imagine a celestial particle accelerator where atoms are ripped apart, their electrons knocked loose, then violently recombined. Each collision releases bursts of light at wavelengths we've never catalogued, producing those eerie, shifting hues. Then there's the storm's shape or lack thereof. Most cosmic clouds have defined edges, sculpted by stellar winds or gravity. The chromatic storm, though, seethes and expands unpredictably, as if it's alive. One week, telescopes capture it stretching into tendrils. The next, it contracts into a dense, glowing knot. Some astrophysicists think it's trapped in a feedback loop. The magnetar's radiation excites the gas, causing it to expand, only for gravity to pull it back, triggering new collisions in an endless cycle. Others propose something even stranger, that the cloud is laced with exotic matter, particles that decay unpredictably, releasing energy in erratic surges. But the real mystery, the storm's heartbeat, every 42 hours like clockwork, the entire cloud dims for exactly 17 minutes before flaring back to life. No known stellar process matches this rhythm. Could it be the magnetar's rotation aligning just right to cast a shadow, or something more profound, a gateway to another dimension, pulsing like a distant lighthouse? Whatever the answer, the chromatic storm refuses to fit into our models, a dazzling reminder that the universe's palette is far richer and far weirder than we ever imagined. Buried in the swirling outskirts of NGC 262, there's a world that gleams like a jewel tossed into the void, the Diamond Core planet. This isn't some poetic exaggeration. Its very heart is a crystalline behemoth, a sphere of compressed carbon so vast it could dwarf entire mountain ranges. When light from nearby stars strikes its surface, the planet doesn't just reflect, it scatters, sending prismatic shards of radiance flashing in every direction like a celestial disco ball spinning in slow motion. How does something so dazzling even exist? The answer lies in pressures beyond human comprehension. Most planets form with molten cores of iron or nickel, their interiors churning with heat and magnetism. But this world endured conditions so extreme that carbon atoms, normally content to form humble graphite or coal, were crushed into perfect crystalline lattices. Imagine the weight of 1,000 atmospheres pressing down, not for centuries but for billions of years, until the very laws of chemistry bent to the will of gravity. What emerged wasn't just diamond, it was a super-dense, superconducting form of carbon that shouldn't be stable at planetary scales. Astronomers are still grappling with the implications. Standard models suggest such a core should have fractured under its own rigidity or sunk into the mantle long ago, yet here it is, defiantly intact, its surface scarred by diamond-coated mountain ranges that gleam under starlight. Some theories point to an apocalyptic collision in the planet's youth, where two protoplanets smashed together with such force that their carbon-rich cores fused into this impossible gem. Others speculate about exotic quantum effects, where the diamond structure somehow locked itself into place, resisting the chaos that should have torn it apart. Then there's the light show. Unlike Earth's muted reflections, this planet's diamond core acts like a cosmic prism, bending and amplifying starlight into vibrant hues. During eclipses, when its host star slips behind it, the planet doesn't darken, it ignites, casting rainbow halos across nearby dust clouds. It's as if the universe itself is showing off, reminding us that even the coldest depths of space can harbor unimaginable brilliance. But the real puzzle isn't just how this world formed, it's what it means for others like it. If one diamond core can exist, could there be entire classes of crystalline planets lurking in the dark, their interiors glittering with alien gemstones? The discovery forces us to rewrite the rulebook on planetary diversity, proving once again that NGC 262 isn't just a gallery of oddities, it's a workshop where the cosmos experiments with the impossible. Among the 30 cosmic oddities in NGC 262, few are as unsettling as the ones that refuse to stay put or play by the rules. Take the trio of vanishing stars, a set of 3 suns that flicker in and out of existence like candles in a cosmic wind. One moment they burn bright in telescopic observations, their spectra matching known stellar types, the next gone, not dimmed, not obscured, erased, as if the universe itself hit the delete key. Then weeks or months later, they reappear in the exact same spot, unchanged as though nothing happened. It's not an instrument glitch, multiple observatories have confirmed it. These stars vanish and return with a randomness that defies every model of stellar behavior. What could cause such a phenomenon? One theory suggests they're trapped in a region of spacetime so warped that it acts like a celestial turnstile, briefly swallowing the stars into a hidden dimension before spitting them back out. Another idea points to quantum tunneling on a stellar scale, a freak chance that the entire star momentarily leaps into an improbable state, vanishing before snapping back. But the most spine-tingling hypothesis, that we're seeing echoes of stars long dead, their light somehow looping back through time, replaying their final moments like a cosmic recording stuck on repeat. Not far from this stellar enigma lies the gravity lens anomaly, a patch of space that bends light wrong. Gravitational lensing is a well-documented effect. Massive objects like galaxies distort spacetime, bending light from objects behind them into arcs or rings. But this lens doesn't follow the script. Light passing through it doesn't curve smoothly. It fractures, splitting into jagged, disjointed beams like sunlight through broken glass. Calculations show the anomaly's mass isn't nearly enough to cause such extreme distortion, yet the effect is undeniable. Some researchers think this could be a knot in spacetime itself, a defect left over from the universe's birth, where the fabric of reality folded back on itself. Others whisper about negative mass, a hypothetical substance that repels gravity instead of attracting it, scrambling light like a hall of mirrors. If proven, it would upend our understanding of cosmic architecture, revealing flaws in the very scaffolding of existence. Then there's the silent pulsar, perhaps the most paradoxical of the 3. Pulsars are the lighthouses of the cosmos, rapidly spinning neutron stars that blast beams of radiation with metronome precision. We detect them by their rhythmic pulses, usually in radio waves or X-rays, but this one, it spins at breakneck speed, its surface whirling so fast it should scream across the electromagnetic spectrum. Yet our instruments hear nothing. No radio bursts, no X-ray ticks, just eerie stillness where there should be cosmic fireworks, the leading explanation. It might be spinning too perfectly. Most pulsars wobble slightly, their beams sweeping past Earth like a lighthouse's rotating lamp. But if this pulsar's spin is flawlessly aligned, its beams locked in place like a laser pointer aimed away from us, we'd never detect its pulses. Alternatively, its magnetic field could be so tangled that it smothers its own emissions, a cosmic mute button pressed by forces we don't yet understand. Together, these 3 phenomena, vanishing stars, fractured light, and a silent beacon, paint NGC 262 as a realm where the universe's rules aren't just bent, they're rewritten. Each one taunts us with the same unsettling truth: there's so much we still don't know, and the cosmos is far stranger than we dare to assume. The organic halo is one of those discoveries that blurs the line between chemistry and biology, dangling the tantalizing possibility that we're glimpsing the universe's recipe for life itself. Picture a dying star, a red giant in its final throes, shedding its outer layers into space, but instead of just scattering simple gases, it's surrounded by a shimmering ring of complex organic molecules. We're not talking about scattered specks of methane or carbon monoxide. This halo contains compounds like formaldehyde, acetic acid, and even glycine, the simplest amino acid. These are the building blocks of proteins, the very ingredients that, under the right conditions, could assemble into something far more intricate. What makes this ring so extraordinary is its defiance of expectations. When stars like this near the end of their lives, they typically expel heavier elements like oxygen or silicon, not delicate organic chains. Yet here, the stellar winds seem to have woven a fragile tapestry of carbon-based molecules, as if the star's final act was to whisper the secrets of chemistry into the void. Some researchers argue this could be a snapshot of prebiotic processes, the same reactions that, billions of years ago, might have seeded Earth's primordial soup. Imagine it, a dying sun in its last breaths, crafting the raw materials for life and flinging them into the cosmos. But there's another, more skeptical take. Interstellar space is littered with dust clouds rich in organic material, and it's possible this halo isn't homegrown at all. Instead, the star's expanding shell might simply be sweeping up pre-existing molecules, like a snowplow gathering debris. If that's the case, the halo isn't a testament to stellar alchemy, it's just a cosmic accident, a fleeting alignment of unrelated phenomena. Yet even this explanation raises questions. Why are these molecules so densely concentrated here, and why do they form such a perfect, symmetrical ring? The debate hinges on a deeper mystery. How resilient is organic chemistry in the chaos of space? Laboratory experiments show that many of these compounds can survive harsh radiation and freezing temperatures, but out there, exposed to the full fury of a dying star's ultraviolet glare, they should be ripped apart. Unless, of course, some unseen force is shielding them. Could magnetic fields or pockets of dense gas be acting as cosmic greenhouses, nurturing these fragile structures long enough for us to detect them? Then there's the most provocative question of all. If this star can create or preserve such complexity, how many others have done the same? The universe is littered with red giants, each a potential factory for life's ingredients. We might be looking at a single thread in a vast interstellar tapestry, one that stretches far beyond NGC 262. Whether the organic halo is a creator or a curator, its very existence nudges us closer to answering one of humanity's oldest questions. Are we alone, or is the universe quietly, patiently, assembling the pieces of life wherever it can? Floating in the shadow of a gas giant within NGC 262, there's a moon that shouldn't exist, not intact anyway. The fractured moon hangs in space like a broken jigsaw puzzle, its jagged fragments suspended in a slow-motion ballet, each piece separated by miles yet never drifting apart. It's as if someone took a hammer to a globe, then left the shards hovering in midair, held together by nothing more than a whisper of gravity. Most moons this shattered would have collapsed into a ring of debris or crashed into their parent planet eons ago. But this one, it defies every expectation, clinging to its fractured existence with eerie persistence. The surface tells a story of violence. Canyons wider than continents slice across its terrain, their edges sharp as knife blades, untouched by erosion. Impact craters overlap in chaotic layers, hinting at a history of relentless bombardment, but the real mystery lies in the gaps, the yawning voids between the moon's fragments, where gravity's grip is so weak that a human could leap from one piece to another with ease. Somehow these fragments maintain a delicate equilibrium, their orbits around each other so precise that they've avoided collision for millions of years. What could have caused such a catastrophic breakup? The leading theory points to a rogue asteroid strike, but not just any impact. This would have been a collision so perfectly angled, so unnervingly precise, that it didn't shatter the moon so much as unzip it, sending fractures racing through its core like cracks in ice. Simulations suggest the asteroid might have been unusually dense, a cannonball of iron or platinum, striking at just the right speed to fragment the moon without scattering it entirely. Alternatively, the moon's interior could have been riddled with caverns or volatile ices, turning it into a cosmic house of cards that collapsed at the slightest nudge. Then there's the darker possibility that this wasn't an accident at all. Some astronomers speculate the fractures might be the work of tidal forces gone haywire. If the moon's orbit once brought it too close to its gas giant, the planet's gravity could have stretched and squeezed it like putty, pulling it apart from the inside. Perhaps the moon was even part of a binary system, two moons circling each other until their dance turned deadly, ending in a slow-motion collision that left one in ruins. But the most haunting question isn't how the fractured moon came to be, it's how long it can last. Right now, the fragments hover in a fragile truce, but one wrong tug from a passing comet or a shift in the gas giant's tides could send them spiraling away, or crashing together in a final, cataclysmic reunion. Every observation we make could be capturing its last moments of stability, a fleeting glimpse of a cosmic anomaly on the brink of vanishing forever. And that's what makes it so mesmerizing. In a universe where most destruction is swift and absolute, this moon lingers, a ghost of its former self, whispering secrets about the delicate balance between chaos and order. Hidden behind the veil of NGC 262's spiraling arms, a quasar pulses with light that moves as if dragging itself through cosmic molasses. This isn't just a trick of perspective, it's a fundamental distortion of time itself. The time-dilated quasar emits energy bursts that should arrive at Earth in crisp, predictable intervals, but instead they stretch and stutter, their signals arriving seconds or even minutes late. It's like watching a video buffering in slow motion, except the universe itself seems to be pressing pause on the laws of physics. What could bend time so severely? The answer might lie in the fabric of spacetime at its smallest scales. Some theorists suggest this quasar sits atop a knot of quantum foam, a hypothetical froth of microscopic spacetime fluctuations where the very underpinnings of reality churn chaotically. Imagine walking across a trampoline pockmarked with tiny, invisible pits. Your steps would falter, your path uneven. Light passing through such a region would stagger, its waves scrambled by the foam's turbulence. If true, this quasar could be our first glimpse of spacetime's granular texture, a place where the smooth continuum Einstein described frays into something far stranger. Then there's the dimension hopper hypothesis. Could the quasar's light be dipping in and out of hidden dimensions, momentarily vanishing into realms we can't perceive before snapping back into our universe? In some string theory models, extra dimensions curl in on themselves, too tiny to detect except where gravity or light leaks through. The quasar's delayed signals might be echoes from these unseen layers, as if its photons are taking detours through corridors we can't map. But the most unsettling possibility, that we're witnessing time itself decay. In certain exotic physics models, the constants of nature, like the speed of light, aren't immutable. They could vary across the cosmos or even erode over eons. If time flows slower near this quasar, it might hint that the universe's rules are looser, messier than we thought. The implications ripple far beyond NGC 262. If time can stretch here, where else does it warp, and what does that mean for our own corner of existence? Every delayed pulse from this quasar forces us to confront the unnerving truth: the universe might not just contain mysteries, it might be one. The time-dilated quasar doesn't just toy with the flow of time, it taunts us with contradictions written in its very light. At the heart of the mystery lies its redshift, the stretching of light waves that tells us how fast an object is moving away from us. Normally, redshift is a cosmic speedometer, reliable and straightforward. But this quasar's light tells two different stories at once. Some of its spectral lines redshift as expected, placing it billions of light-years away. Others, though, appear bizarrely blue-shifted, as if parts of it are rushing toward us while the rest flees. It's like hearing a train whistle that simultaneously rises and falls in pitch, a physical impossibility, unless the train is somehow moving in two directions at once. What could cause such a paradox? One clue might lie in the quasar's structure. Most quasars are thought to be supermassive black holes at the centers of galaxies, devouring matter so voraciously that their accretion disks glow brighter than entire star systems. But this one could be different. Imagine not just one black hole, but two locked in a tight orbit, their gravitational chaos warping the light they emit. As they whirl around each other, one might periodically slingshot matter toward us, creating those anomalous blue-shifted signals. Alternatively, the quasar's disk might be so violently turbulent that pockets of gas are ejected outward at extreme speeds, like sparks from a grinding wheel, skewing the redshift data into nonsense. Then there's the time capsule angle. Quasars are cosmic lighthouses, their light taking eons to reach us. Normally, that light is a snapshot of the universe's youth, a glimpse into conditions long past. But this quasar's time-bending properties could mean its light is older than it appears, or perhaps younger. If its photons were delayed by space-time's wrinkles, we might be seeing it not as it was billions of years ago, but as it was at multiple epochs simultaneously. Picture a river where upstream and downstream waters swirl together in the same eddy. That's the kind of chronological chaos we're dealing with, a beacon that could be showing us the past, present, and future all at once. The implications are staggering. If we can untangle this quasar's conflicting signals, we might unlock secrets about the universe's expansion, the nature of dark energy, or even the validity of relativity itself. Some theorists whisper that this could be a crack in cosmic orthodoxy, a hint that redshift isn't the infallible ruler we thought it was, or that spacetime's fabric is far more malleable than Einstein predicted. Others see it as a Rosetta Stone for decoding quantum gravity, the elusive theory that could unite relativity with the subatomic world, but the most tantalizing idea. That this quasar isn't an anomaly at all, maybe it's the first of many, a signpost pointing toward a deeper layer of cosmic truth we've only begun to scratch. Every flicker of its paradoxical light challenges us to rethink what we know, and to wonder what else the universe has been hiding in plain sight. Imagine a nebula that doesn't just glow, it breathes. Drifting through NGC 262, the metallic bioluminescence cloud pulses like a living thing, its shimmering expanse of iron and nickel expanding and contracting in a slow, hypnotic rhythm. Unlike typical emission nebulas, which shine with the scattered light of newborn stars, this cloud's radiance comes from within, as if its very atoms are vibrating in unison to some cosmic heartbeat. And the strangest part, the pulses aren't random. They follow a precise, repeating sequence: 92 seconds of brightening, then 92 seconds of dimming, over and over, with unerring consistency. The presence of heavy metals alone makes this cloud an oddity. Iron and nickel usually sink into the cores of planets or stars, not float freely in space. Yet here they are, suspended in a vast, luminous mist, their spectral fingerprints unmistakable in telescopic data. Even more baffling is how they emit light at all. These metals don't fluoresce like hydrogen or helium when bombarded by starlight. Their glow suggests something far more exotic, a self-sustaining reaction, perhaps driven by an unseen energy source or an entirely unknown form of plasma physics. One radical theory proposes that the cloud isn't just reacting to external forces, it might harbor structures that organize it. Magnetic filaments, twisted into helical shapes, could be channeling energy through the cloud like cosmic neurons, creating those rhythmic pulses. On Earth, certain bacteria align with magnetic fields to navigate. Could this nebula's behavior hint at something analogous? but on a scale spanning light years. It's a stretch but not impossible. If magnetic fields can spawn complexity in the chaos of space, who's to say what forms that complexity might take? Then there's the plasma angle. Under extreme conditions, ionized gas can exhibit lifelike behaviors, self-organizing into cells, filaments, or even double layers that store and release energy. The cloud's pulses might reflect a natural oscillator in the plasma, a feedback loop where accumulated charge periodically discharges in a brilliant flash. Some lab experiments on Earth have recreated similar pulsations in miniature, though nothing approaching the scale of this celestial phenomenon, but the most tantalizing clue lies in the timing. 92 seconds isn't just a number, it matches the rotational period of a nearby neutron star. Could this dead star's spinning magnetic field be inducing the cloud's rhythm, like a conductor guiding an orchestra, or is the synchronization pure coincidence, a cosmic mirage that tempts us to see connections where none exist? Every hypothesis unravels as quickly as it forms, leaving us with more questions than answers. One thing's certain, this isn't just another cloud, it's a dynamic, almost defiant anomaly, challenging us to rethink where and how the boundary between chemistry and life might truly lie. Buried among the rocky debris drifting through NGC 262, there's an asteroid that shouldn't exist, at least, not in its current form. From the outside it looks like any other space rock, pockmarked and unremarkable. But peer inside with radar and gravitational scans, and the truth emerges: this asteroid is hollow, not just partially eroded or loosely packed, but a vast, echoing shell, its interior carved into geometric tunnels so precise they look machined. Straight lines, right angles, and symmetrical chambers stretch for miles beneath its surface, forming a labyrinth that defies every known law of natural erosion. How does something like this form? The most unsettling explanation is also the simplest: someone or something dug it out. The tunnels show signs of tool marks, with edges too sharp to be formed by impacts or geology. Some astronomers speculate it could be the remnants of an ancient mining operation, a celestial quarry stripped bare by a long-vanished civilization. Imagine a species so advanced they didn't just visit asteroids, they dismantled them, harvesting metals and minerals down to the last vein before abandoning the hollowed husk to drift through eternity. The asteroid's composition lends credence to this idea. Its outer crust is rich in platinum group metals, exactly the kind of rare resources an industrial society might covet. But there's a counterargument that's equally bizarre. Certain types of extreme volcanic activity, combined with tidal forces from a nearby gas giant, could theoretically sculpt tunnels like these, if the conditions were perfect. The asteroid might have once been molten, its interior bubbling with gas pockets that collapsed in just the right sequence to create these eerie passageways. Proponents of this theory point to similar, though far less dramatic, formations on moons like Io, where volcanic plumes have carved sinuous channels. The problem: no natural process explains the regularity of these tunnels. Nature abhors right angles, yet here they are, repeated with near mathematical precision. Then there's the third option: the asteroid isn't natural or artificial, but something in between. Certain self-organizing chemical reactions can produce intricate, geometric structures under controlled conditions. Could a freak combination of heat, pressure, and exotic chemistry have turned this rock into a cosmic termite mound, its tunnels growing like crystal lattices? It's a fringe idea, but not impossible. The universe has a way of repeating patterns at every scale, from the branching of neurons to the spiral arms of galaxies. Maybe this asteroid is just another example, albeit one that feels engineered. The most haunting question isn't how it formed, though, it's why it's still here. Hollow structures are fragile, vulnerable to the slightest impact, yet this asteroid has survived for millions, possibly billions of years, its tunnels intact. Is it shielded by some unseen force, Or are we witnessing a fossil of sorts, the last remnant of a phenomenon or a civilization we'll never fully understand? Every scan, every measurement only deepens the mystery, turning this unassuming rock into one of NGC 262's most unsettling puzzles. At the fringes of NGC 262, a cosmic rebel drifts in silent defiance, the counterspin galaxy fragment. This jagged shard of stars and dust, roughly a tenth the size of its parent galaxy, spins backward, its rotation axis tilted a full 180 degrees from the rest of NGC 262. It's like watching a gear in a machine suddenly reverse direction, grinding against the cosmic clockwork. Galactic fragments usually inherit their motion from the larger structure they broke away from, but this one, it moves to its own rhythm, as if some unseen hand reached in and flipped its celestial switch. What could cause such a contradiction? One clue lies in its composition. The fragment is laced with unusual metals, elements typically forged in the hearts of massive stars, but scattered here in abnormal concentrations. This suggests a violent origin story. Perhaps two smaller galaxies collided long ago, their merger so chaotic that a rogue cluster of stars was hurled backward, spinning counter to the tidal forces that birthed it. Alternatively, the fragment might have once orbited another galaxy entirely, captured by NGC 262's gravity, but retaining its original rotation like a cosmic trophy refusing to assimilate. Then there's the dark matter angle. Simulations show that dense pockets of dark matter can warp the spin of celestial objects, twisting their trajectories like invisible fingers nudging a top. If this fragment carries an uneven distribution of dark matter, say, a clump offset from its visible mass, it could explain the backward motion. But here's the twist: no known dark matter model predicts such an extreme reversal. Unless, of course, we're dealing with something even stranger, a form of dark matter that repels ordinary matter, creating a gravitational push instead of a pull. Not far from this celestial maverick lies an even more confounding phenomenon: the reverse entropy zone. Entropy, the universal tendency toward disorder, is one of physics' most ironclad laws. Drop a glass and it shatters, scramble an egg and it never unscrambles itself unless you're inside this region of NGC 262. Here, matter behaves like a video played in rewind. Gas clouds scattered by supernova slowly recoalesce. Radiation emitted by stars bends back toward its sources as if drawn by an unseen tide. It's as though time's arrow has flipped, granting this pocket of space a temporary exemption from thermodynamics. The leading theory: the zone might sit at the eye of a quantum vortex, a swirling eddy in spacetime where the fabric of reality itself frays. In such a region, the usual rules of cause and effect could temporarily invert, allowing entropy to run backward. Another idea suggests the influence of negative energy densities, exotic states predicted by quantum field theory that could hypothetically reverse the flow of time on microscopic scales. If amplified by some unknown cosmic mechanism, these effects might spill over into the macroscopic world, creating the illusion of unmixing. But the most unsettling possibility is that we're not seeing reverse time at all. Instead, the zone could be a projection, a holographic echo of another universe with opposite physical laws, bleeding through a crack in spacetime. Imagine two soap bubbles pressed together. Where they meet, their surfaces briefly share properties. If our universe touches another where entropy decreases with time, the boundary might shimmer with these impossible reversals. Together, the counter-spin fragment and the reverse entropy zone challenge more than just our models of galactic mechanics. They poke holes in our understanding of reality's bedrock. One defies the rules of motion, the other laughs in the face of time. And their proximity raises a chilling question: are these anomalies linked? Could the fragment's backward spin have torn a rift in spacetime, birthing the entropy zone? Or is NGC 262 simply a cosmic dumping ground where the universe stashes its most inconvenient contradictions? Either way, they remind us that for every law we've written, the cosmos has a loophole. Floating in the depths of NGC 262, an eerie silhouette reaches out as if begging to be noticed, the ghostly radio hand. This nebula stretches across light years, its wispy fingers curled into an unmistakable gesture, like a cosmic plea frozen in time. But what chills astronomers isn't just its shape, it's the whispers. Faint radio pulses ripple from the structure, pulsing in patterns that dance unsettlingly close to human-made signals. The first time telescopes detected it, researchers actually double-checked their equipment, convinced someone had left a transmitter on. The hand's radio emissions don't match any known natural source. Most cosmic radio waves come from synchrotron radiation, charged particles spiraling around magnetic fields, but these pulses are too clean, too rhythmic. They arrive in bursts of 5 with intervals that mirror the primes, 2, 3, 5, 7, 11 seconds apart. Prime numbers are nature's rare gems, seldom appearing in random noise, yet here they are, etched into the void. It's the kind of pattern we'd expect from an intentional beacon, not a cloud of ionized gas. Could this be evidence of something more? Skeptics point to magnetars, neutron stars with magnetic fields strong enough to distort atoms, as a possible culprit. If one lurks inside the hand, its twisted magnetism might sculpt the nebula into that uncanny shape while generating those peculiar pulses, but even the most extreme magnetar models struggle to explain the prime number cadence. Nature loves chaos, it doesn't count. Then there's the plasma resonance theory. Under specific conditions, superheated gas can vibrate like a struck bell, producing harmonic frequencies. If the hand structure acts as a natural resonator, perhaps its geometry amplifies certain pulses while suppressing others, creating the illusion of order. It's a stretch, but not impossible. Think of how wind whistling through a canyon can sound eerily like voices, yet the most haunting detail lies in the hand's movement. Over decades of observation, its fingers have slowly curled tighter, as if grasping toward something unseen. Is it collapsing under its own gravity, or is there something else pulling at it? The mystery deepens with every passing year, a silent reminder that in NGC 262, even the emptiness seems to watch back. Nestled in the heart of NGC 262, the quantum crystal reef is a spectacle that would make even the most seasoned physicist question reality. Picture this, a sprawling field of translucent structures, each one shimmering like ice but pulsing with an eerie inner light, drifting through the void like fragments of a shattered chandelier. At first glance they resemble ordinary cosmic crystals until you look closer. The moment telescopes focus on them, their properties shift, colors flicker from ultraviolet to infrared in an instant, their molecular vibrations slow or speed up as if reacting to the act of observation itself. It's as if these crystals know they're being watched. This isn't just some celestial parlor trick, it mirrors one of quantum mechanics' most baffling phenomena, the observer effect. On Earth, tiny particles like electrons change behavior when measured, existing in a haze of probabilities until observation forces them into a defined state. But here that effect scales up to macroscopic levels, with entire crystal structures reacting to the gaze of our instruments. Some theorists argue this could be a natural example of quantum decoherence pushed to extremes, where the boundary between quantum weirdness and the classical world blurs. If true, the reef might be a cosmic laboratory, demonstrating how quantum rules could govern larger systems under the right conditions. Then there's the darker interpretation. These crystals might not be natural at all. Their geometry is too precise, facets cut at angles found nowhere in known mineralogy, their edges sharp enough to slice light into spectral ribbons. Could they be artifacts of a civilization that harnessed quantum engineering? Ancient probes perhaps designed to cloak or transform when scrutinized. The idea isn't as far-fetched as it sounds. Human technology already toys with quantum encryption. Imagine a culture millennia ahead, encoding their structures to reconfigure at the slightest attention, like a cosmic version of reactive camouflage. But the reef's most unsettling feature is its silence. Unlike pulsars or quasars, it emits no radio noise, no X-ray bursts, just that uncanny, watchful shimmer. Even its temperature defies logic. Infrared scans show it absorbing heat from surrounding starlight, yet its surface remains colder than the void around it, as if siphoning energy into some hidden dimension. Some models suggest the crystals might be tapping into zero-point energy, the quantum froth of spacetime itself. Others propose they're not even matter as we understand it, but rather knots of spacetime curvature, frozen ripples in the fabric of reality. Every attempt to study the reef raises more questions. Point a spectroscope at it, and the readings shift mid-measurement. Map its magnetic fields, and they rearrange like living things avoiding capture. It's a cosmic hall of mirrors, reflecting our own limitations back at us. Whether a natural wonder or something far more profound, one thing's certain: the quantum crystal reef doesn't just defy expectations, it redefines them, one observation at a time. In the silent void of NGC 262, a black hole sings, not in the way stars hum with radiation or pulsars beat like cosmic drums. This is a deep, resonant tone, a frequency so precise it echoes the golden ratio, the fundamental mathematical constant found in everything from seashell spirals to galaxy arms. Most black holes are known for their silence, their gravitational grip so strong that not even light escapes, but this one vibrates, sending out waves that ripple through spacetime itself, a cosmic bass note trembling across the cosmos. What could cause such a phenomenon? The leading theory points to the black hole's event horizon, the point of no return, where space and time twist into chaos. Normally, matter falling inward is torn apart silently, but here the debris might be moving in a perfect rhythmic cascade. Picture water spiraling down a drain, creating whirlpool patterns, except in this case, the water is superheated plasma, and the drain is a singularity warping reality itself. If the infalling matter reaches just the right speed and density, it could generate vibrations, like fingers running along the rim of a wineglass. Even stranger is the pitch itself. The frequency doesn't just match any mathematical constant, it aligns with phi, the golden ratio, a number that appears in nature's most harmonious designs. Coincidence unlikely. Some researchers suggest the black hole's rotation might be tuned to this ratio, its spin so perfectly balanced that it resonates with the fabric of the universe. Others speculate that the event horizon itself could be acting like a cosmic string, vibrating in higher dimensions we can't perceive directly. Then there's the eerie implication: is this black hole communicating? Mathematicians have long pondered whether constants like phi are universal, a language woven into the cosmos itself. If so, this black hole might be less a destroyer and more a messenger, humming a note that transcends space and time. Or perhaps it's just a fluke, a celestial accident that sounds intentional, like a random radio signal mistaken for a greeting. One thing's certain: the singing black hole defies our expectations of what these cosmic monsters can do. It doesn't just consume, it resonates, turning the violent act of annihilation into something almost beautiful, and with every harmonic pulse, it whispers a question we're only beginning to ask: is the universe itself a symphony, and are we just now learning to hear the notes? The deeper we listen, the more the singing black hole's melody reveals its impossible precision. These aren't random vibrations, they're mathematical perfection, harmonics aligning with geometric ratios found in everything from DNA helices to distant spiral galaxies. Each oscillation traces the golden ratio signature, a pattern so universal it feels less like coincidence and more like design. Imagine the universe as a grand piano. Most black holes are silent hammers, but this one strikes a chord that resonates across dimensions. What makes these sound waves even more extraordinary is how they travel. Spacetime isn't just the stage for this performance, it's the instrument itself. As the black hole's gravity warps the fabric of reality, it creates standing waves. rhythmic ripples that propagate like notes through a cosmic violin string. Unlike the chaotic screech of colliding neutron stars or the white noise of quasar jets, this tone is pure, almost deliberate. Some astrophysicists argue it's the result of a perfect storm, a black hole spinning at exactly the critical speed where its event horizon becomes a resonant chamber, amplifying specific frequencies while suppressing others. But here's where it gets unsettling. The golden ratio isn't just aesthetically pleasing, it's computationally efficient. In human engineering, we use it to optimize antennas and acoustic spaces. Could this black hole be doing the same? One radical theory suggests these vibrations might stabilize its structure, like a singer shattering a glass by hitting the precise pitch that matches its natural frequency. If true, the black hole isn't just singing, it's fine-tuning itself, using sound to maintain equilibrium in the chaos of its own gravity. Then there's the message hypothesis. Throughout history, humans have used mathematical constants as universal languages, from Fibonacci sequences engraved on ancient artifacts to the binary coded aboard the Voyager probes. If an advanced civilization wanted to broadcast its presence across time and space, encoding a signal in the golden ratio would be a brilliant strategy, a beacon any species with grasp of mathematics would recognize. Of course, the universe is under no obligation to cater to our search for meaning. The vibrations could simply be a fluke of physics, a pattern we anthropomorphize because our brains are wired to seek order. Yet the eeriest possibility lies in the wave's longevity. Most cosmic sounds fade as space-time stretches, their wavelengths diluting into silence, but these pulses persist, their clarity undimmed after traveling millions of light years. It's as if the black hole's song is etched into the universe's fabric, a groove in the record of reality that never wears thin. Whether it's a message, a self-preservation mechanism, or just a fleeting cosmic chord, one thing is certain: the singing black hole refuses to be ignored. With every oscillation, it challenges us to reconsider not just how black holes behave, but how the universe itself might be speaking in a language we're only beginning to decipher. Somewhere in the swirling depths of NGC 262, a celestial paradox hangs suspended in the void, a flawless ring of stars encircling absolute nothingness. The impossible ring glows with the light of 100 suns, its symmetry so precise it looks like a cosmic bull's eye painted across the darkness. But here's what defies all logic: there's no central mass holding it together. No black hole and no galaxy core, not even a dense cluster of dark matter, just empty space, as if the stars decided to dance around an invisible king. Orbital mechanics demand that such a structure should collapse instantly. Stars need gravity to orbit, and gravity requires mass, something this ring's center conspicuously lacks. It's like watching a carousel spin without a central pole, its horses magically suspended in midair. Some astronomers argue we might be seeing a glitch in the cosmic simulation, a fleeting error in the universe's code where the rules of physics briefly falter. The idea isn't as outlandish as it sounds. Scientists already use simulations to model galactic behavior, and glitches do occur. Could this ring be evidence that reality itself is just an unimaginably complex projection, and we've stumbled upon a bug in the system? Then there's the space-time warp hypothesis. Imagine a region where the fabric of the universe is pinched like a twisted bedsheet, creating a gravity well so steep that stars are funneled into a perfect circle around nothing. Theoretical models of wormholes or higher dimensional brains could produce such an effect, warping light and matter into unnatural configurations. If true, the impossible ring might be a cosmic porthole, a ripple in dimensions we can't perceive, its true nature hidden just beyond the edge of our understanding. But the most unsettling possibility, that we're witnessing the aftermath of a celestial heist. Some theorists speculate a supermassive object, a black hole or exotic matter construct, once anchored this ring before vanishing without a trace. Perhaps it was ejected by a cataclysmic collision, Or maybe it collapsed into a state so dense it slipped through space-time itself. The stars, still bound by the ghost of its gravity, continue their endless march, circling a throne that's no longer there. Every observation deepens the mystery, leaving us to wonder, is the impossible ring a flaw in reality's design, a window into the unseen, or the universe's way of reminding us that some questions refuse to be answered? Among the swirling cosmic tapestries of NGC 262, one nebula stands out not for its shape or size, but for its color. The blood-red nebula glows with a hue so deep and unsettling, it looks less like a cloud of gas and more like a wound carved into the fabric of space itself. Most nebulas shimmer in blues or pinks, their palettes dictated by familiar elements like hydrogen and oxygen, but this one, it pulses in shades of crimson and burgundy, as if stained by some celestial massacre. The color defies easy explanation. Ordinary interstellar dust can redden light, much like Earth sunsets, but this nebula's hue is too intense, too pure. Spectroscopic analysis reveals no traces of iron oxide, the compound that paints Mars rust red, or any other known mineral. Instead, the nebula brims with unfamiliar molecular signatures, carbon chains twisted into configurations lab chemists have never replicated. Some researchers speculate these could be polycyclic aromatic hydrocarbons, complex organic molecules typically found in soot or smog, but cooked here under pressures and temperatures that warp them into something new. Imagine taking the scent of a campfire and forging it into a gemstone. That's the kind of alchemy we're witnessing. Then there's the light itself. The nebula doesn't just reflect starlight, it transforms it. Photons passing through seem to lose energy in staggered steps, bleeding down the spectrum until they emerge as that eerie crimson. It's as if the cloud is a cosmic filter, selectively absorbing and re-emitting light in ways that shouldn't be possible. One theory suggests the presence of plasma crystals, exotic states of matter where charged particles organize into lattice-like structures, bending light like a prism made of charged mist. Another idea points to quantum dots, nanoscale particles that alter light based on their size, though how such precision could arise naturally in the chaos of space remains a mystery. But the most haunting detail, the nebula's glow isn't static. It brightens and dims in sync with a nearby neutron star's rotation, as if the star's magnetic field is stirring the cloud like a spoon in a cauldron. Every 11 hours, the crimson deepens, then fades a slow, rhythmic pulse that gives the nebula an almost lifelike presence. Is this some undiscovered form of stellar symbiosis, or merely a coincidence written in light? The blood-red nebula refuses to fit neatly into our catalogs or theories. It's a reminder that the universe's palette is vaster than we've dared to imagine, and that even something as simple as color can hold secrets we're only beginning to unravel. Whether it's a cosmic accident or a sign of chemistry we've yet to understand, one thing's certain: in the black and white equations of astrophysics, this nebula is a vivid splash of the unknown. In the cosmic menagerie of NGC 262, three objects stand apart not just for their strangeness, but for their uncanny resemblance to things built, not born. First, the self-replicating probe, a sleek, metallic structure drifting between stars, its surface etched with geometric patterns too precise for natural erosion. When telescopes first spotted it, the assumption was a rogue asteroid until it split. Over 12 Earth years, the object divided cleanly down the middle, each half regenerating into a perfect copy of the original. Now there are 4, then 8. The process isn't chaotic, it's methodical, algorithmic, as if following instructions coded into its very atoms, the most chilling detail. Scans suggest the probe isn't just copying itself, it's adapting. Each iteration shows minor refinements, like software updating its own code. Whether it's a relic of some ancient civilization or a runaway experiment, one thing's clear: this isn't just an object. It's a process. Then there's the frozen supernova, a stellar explosion caught in cosmic amber, Supernovas are the universe's most violent fireworks, their fury typically measured in weeks. But this one, it's been suspended mid-detonation for centuries, its shockwaves arrested like a paused film reel. The outer layers of the star hang in shimmering filaments, frozen mid-expansion, while the core pulses at temperatures that defy physics, somehow neither collapsing further nor erupting anew. The leading theory involves quantum lock, a hypothetical state where matter becomes stuck between two phases, like water neither liquid nor ice. Imagine a bomb that never finishes exploding, its fireball trapped in perpetual bloom. Some astronomers whisper this could be deliberate, a celestial stasis field, though whether created by nature or something else remains the galaxy's best-kept secret. And finally, the paradox planet, a world orbiting twin suns in a dance that should make it uninhabitable. Binary systems are notorious for extreme temperature swings, their planets scorched by one star while frozen by the other. Yet this planet boasts near-perfect seasons, its axis tilted just enough to distribute heat evenly. The secret, its orbit traces a figure 8, weaving between the stars with unnatural precision, as if guided by an unseen hand. Geological surveys reveal another oddity. Its crust is laced with metallic veins arranged in fractal patterns, radiating from the poles like circuitry. Some theorists suggest these could be planetary scale stabilizers, technology advanced enough to tweak gravity itself. Others argue it's a fluke, a 1 in a trillion alignment where chaos conspired to create order. Together, these three anomalies taunt us with the same question: where does nature end and engineering begin? The probe replicates, the supernova hesitates, the planet defies, each bending the rules in ways that feel less like accidents and more like choices. Whether remnants of a lost civilization or cosmic coincidences dressed as design, they force us to confront the uncomfortable truth: the universe might not just contain intelligence. It might reflect it. The Mira comet glides through NGC 262 like a cosmic disco ball, its surface so polished it doesn't just reflect light, it captures entire star systems in its icy veneer. Most comets are dusty snowballs, their tails streaking behind them as they shed debris, but this one, its nucleus is a flawless sphere, a kilometer-wide lens of hyper-reflective ice that doesn't melt, doesn't fracture, even as it barrels through the heat of nearby stars. Peer into its surface, and you don't just see a warped reflection of your own telescope, you see galaxies, pinpricks of starlight bent and magnified with impossible clarity, as if the comet's core contains a pocket universe folded into its frozen shell. How does ice achieve such perfection? Normal cometary ice is riddled with cracks and impurities, its structure shattered by cosmic radiation. The Mira comet's surface, though, behaves more like a metamaterial, its molecular lattice engineered to bend light without distortion. Spectroscopy reveals trace elements of exotic metals: rhodium, osmium arranged in geometric patterns that shouldn't form naturally. One theory suggests the comet might be a fragment of a shattered Dyson sphere, a megastructure designed to harness starlight, its reflective properties preserved even in ruin. Others propose it's a natural quantum crystal, its atoms aligned by magnetic fields so intense they freeze light's path like amber trapping prehistoric insects. Then there's the content of the reflections. The star systems mirrored in its surface don't match any in NGC 262 or any known region of the observable universe. Some show configurations that defy orbital mechanics, planets stacked in concentric rings, binary stars sharing a single atmosphere. Are these mirages, warped by the comet's curvature? Or could we be glimpsing other universes, their light leaking into ours through cracks in the ice? The idea isn't pure fantasy. Certain string theory models allow for brain worlds, parallel realities separated by microscopic distances in higher dimensions. If the comet's surface sits at such a boundary, it might act like a two-way mirror, reflecting not just our cosmos but untold others. The most unsettling detail, though, is the comet's silence. It doesn't outgas like ordinary comets, no vapor trail betrays its passage, even as it swings perilously close to stars, its surface remains pristine, untouched by heat or radiation. It's as if the reflections aren't just optical illusions, they're shields, absorbing and dispersing energy across dimensions. Every attempt to probe it fails, radar pings vanish into the glaze, and particles fired at it simply disappear. Whether a relic, a rift, or something beyond our vocabulary, the Mira comet forces a humbling admission: sometimes the universe doesn't just hide its secrets. It holds them up to our faces, lets us stare right into them, and still leaves us blind. At first glance, this stretch of NGC 262 looks like any other patch of star-dusted void, until you drop something. A speck of dust, a stray asteroid, even a wayward satellite. If one were foolish enough to venture here, they don't fall toward the nearest source of gravity. They tumble upward, hurled into the blackness like leaves caught in a cosmic updraft. Astronomers call it the gravity fountain, a place where the universe's most fundamental rule, what goes up must come down, gets rewritten before our eyes. The leading theory blames dark energy. Across the cosmos, this mysterious force pushes galaxies apart, accelerating the universe's expansion. Here, it might be concentrated into geysers, erupting from some hidden wellspring beneath the fabric of space-time. Picture a bubble trapped beneath wallpaper. As it swells, the surface distorts. Now imagine that bubble is pure repulsive energy, and the wallpaper is reality itself. Any object drifting too close gets launched skyward, caught in an anti-gravitational jet stream. But there's a rival hypothesis, one far more unsettling. Spacetime isn't perfectly smooth. At quantum scales, it's theorized to froth with defects, like cracks in frozen lava. The gravity fountain could sit atop one such flaw, a place where the cosmic ground tilts the wrong way. Think of it as a pothole in the road of reality, so deep it inverts the landscape. Objects don't defy gravity here, they obey it perfectly. It's just that down now points toward the void. The most tantalizing clue: the fountain isn't random. Its boundary forms a near-perfect circle, 53 kilometers in diameter, as if drawn with a compass. Within that line, the rules flip. Step outside and normality returns. Such precision suggests structure, maybe even mechanism. Could this be nature's accident, or the scar of something deliberate? Ancient alien engineering, a botched wormhole experiment. The theories spiral as wildly as the debris soaring into the abyss. Watching the fountain at work is like witnessing magic. Gas clouds ribbon upward in ghostly tendrils. Asteroid fragments catapult free, only to freeze and shatter in the vacuum. Even light bends oddly here, creating mirages of distant stars hovering like lanterns above the inversion zone. It's a cosmic carnival ride, one that reminds us how little we truly understand the forces shaping our universe, and how much stranger it might still become. The living dust cloud drifts through NGC 262 like a sentient fog, its particles swirling in formations too deliberate for random chance. Unlike ordinary cosmic dust, passive and scattered by stellar winds, this cloud pulses with eerie coordination, its tendrils expanding and contracting like the breath of some vast, invisible organism. At times it condenses into intricate geometric patterns, hexagons, spirals, even lattice-like grids that linger for days before dissolving back into the void. Then, without warning, it recoils, retreating from nearby radiation sources as if recoiling from a threat. The motions aren't just reactive, they're calculated, almost anticipatory. What could animate such a structure? One possibility tiptoes into the realm of astrobiology. On Earth, microbial life thrives in extremes: deep-sea vents, acidic pools, even the vacuum-hardy tardigrades clinging to spacecraft. Could this dust cloud harbor something analogous? Specks of silica or carbon, woven into thread-like matrices by spaceborne bacteria, their collective movements mirroring the swarming behavior of terrestrial slime molds. It's a tantalizing thought, though no known organism could survive the cloud's exposure to hard vacuum and cosmic rays, unless, of course, it's not life as we recognize it at all. Then there's the darker, more mechanical interpretation. The cloud's behavior bears uncanny resemblances to theoretical nanotech swarms, microscopic machines designed to self-organize into larger structures. Imagine trillions of tiny robots, each no larger than a grain of pollen, communicating through quantum entanglement or magnetic pulses, their collective intelligence shaping the cloud's movements. Ancient civilizations, if they existed, might have seeded the galaxy with such probes, leaving them to drift and adapt over eons. The cloud's sudden recoil from radiation could be programmed avoidance, a relic of some long-forgotten protocol to preserve itself. But here's the twist: the cloud isn't just avoiding threats, it's learning. Over decades of observation, its reactions have grown more efficient, as if refining its responses to stimuli. Early encounters with gamma-ray bursts left it scattered for weeks. Now it reforms within hours. Some researchers argue this could be natural selection playing out on a microscopic scale, with only the hardiest dust structures surviving each cosmic assault. Others see the fingerprints of code, an algorithm gradually optimizing itself. The most haunting question isn't what the living dust cloud is, but why it's here. NGC 262 brims with stellar nurseries and supernova remnants, environments where dust should be annihilated or blown away. Yet this cloud persists, hovering at the galaxy's edges like a watchful sentinel. Is it a relic of some ancient cataclysm, a survivor of a forgotten war between stars, or something far stranger, an experiment left running, its purpose lost to time? Every flicker of its particles feels like a whisper in a language we're only beginning to decipher. The celestial monolith hangs in the void like a silent sentinel, its edges so unnervingly straight they seem carved by tools rather than time. This colossal slab, stretching nearly 12 kilometers long, drifts through NGC 262 with the eerie poise of an artifact waiting to be deciphered. Most cosmic structures wear their origins in jagged craters or swirling gases, but the monolith's surface is flawlessly smooth, reflecting starlight with the cold precision of polished obsidian. It doesn't rotate, it doesn't fracture, it simply is, a geometric anomaly adrift in a universe that otherwise abhors right angles. At first glance, it's impossible not to recall science fiction's most infamous monoliths, those enigmatic slabs from 2001, A Space Odyssey, whispering of unseen architects. Yet reality offers its own parallels. Neutron stars, the collapsed cores of dead suns, sometimes fracture under unimaginable pressures, shedding shards of crystalline crust harder than diamond. Could this be one such fragment, forged in a supernova's heart and flung into the void? The problem: neutron star crusts aren't flat, they're irregular, shattered by the very forces that birth them. The monolith's razor-straight edges suggest something else entirely, a structure shaped by forces we've yet to name. Then there's the composition. Spectroscopic scans return baffling results. The surface absorbs nearly all radiation, leaving no spectral fingerprints, no telltale signatures of iron, silicon, or carbon. It's as if the slab isn't just inert, but designed to hide its nature. Some theorists suggest it could be a Bose-Einstein condensate, a quantum state of matter so dense it behaves as a single monolithic entity. Others propose it's a cosmic strangelet, a hypothetical nugget of quark matter so stable it resists decay across eons. If true, the monolith might be less an object and more a fossil, a relic from the universe's first microseconds, when matter existed in forms now unimaginable. Yet the most unsettling detail isn't what the monolith is, but what it does, or rather what it doesn't. Despite drifting for millennia through a galaxy brimming with gravitational turbulence, its trajectory remains unnervingly linear, as if guided by unseen rails. No nearby star or gas cloud tugs it off course. Even the rare asteroid that strays too close veers abruptly away. its path bending as though repelled by an invisible force field. Is the monolith actively resisting the chaos of space, or is space-time itself warping around it, compelled by some hidden property? Whether a natural wonder or something far more profound, the celestial monolith stands as a testament to the universe's endless capacity to confound. It doesn't just defy expectations, it dismisses them, a silent challenge etched against the stars, and with every unanswered question, it whispers the same unnerving truth: some mysteries aren't meant to be solved. They're meant to humble us. At the edge of NGC 262, where starlight grows thin and the void stretches endlessly, the final cosmic oddity awaits, a nebula that beckons like an invitation written across the heavens. The Doorway Nebula arches against the darkness, its luminous gases curving into a perfect semicircle, flanked by two towering pillars that frame the emptiness within. It looks less like a random cosmic structure and more like a gateway deliberately carved from the fabric of space, a threshold to somewhere or something beyond. The resemblance to a door isn't just poetic coincidence. The nebula's structure defies typical formation patterns. Most nebulas expand in chaotic, asymmetrical blooms, shaped by stellar winds or supernova remnants. This one, though, boasts near-perfect symmetry, its arch maintaining a curvature so precise it could have been plotted with a compass. Some astrophysicists argue it's the result of a rare alignment twin jets from a binary star system, sculpting the gas over millennia into this uncanny shape. Others whisper about more exotic origins. Could it be the mouth of a wormhole, its gravitational lensing bending the surrounding nebula into this eerie silhouette? The math is tantalizing. The arch's diameter matches theoretical estimates for a traversable wormhole's throat, large enough to swallow a starship whole. But the Doorway Nebula's true power lies in its illusion. From certain angles, the void within the arch isn't empty at all. Telescopes have captured fleeting distortions, hints of light bleeding through from the other side, as if the nebula were a smudged window into another region of space. Some images even show background stars warping into streaks, their light stretched like taffy, a telltale sign of extreme gravity. Yet every time researchers adjust their instruments for a closer look, the effect vanishes, leaving only the cold, unyielding dark. Is it a trick of perspective, light bending around dense dust clouds, or a transient portal, flickering open and shut like a door caught in a cosmic breeze? Cultures across the galaxy's rim have myths about this place. The Keshiri of Lyria call it the sky's threshold, a bridge their ancestors crossed to escape a dying world. The Veldran starfarers recite warnings of the Architect's Gate, a trial where only the worthy may pass. Even Earth's early astronomers noted it in their logs as the celestial door, though none could explain its unnerving geometry. These stories share a common thread. The nebula isn't just a structure, it's a test, a challenge, a dare to step through. Science, of course, demands evidence over legend. Yet the Doorway Nebula lingers in that liminal space between fact and folklore, a cosmic Rorschach blot inviting interpretation. Whether a natural marvel, a gravitational anomaly, or something far more profound, its presence closes our journey through NGC 262 with a question rather than an answer. After 30 wonders that shattered our expectations, this final enigma does something even more unsettling. It leaves the door wide open for what we might discover next. The spectral data streaming in from the Doorway Nebula tells a story that telescopes alone could never capture, a tale written in the language of light itself. Near the arch's center, instruments detect pulses of energy that flare and fade like a heartbeat, their signatures defying classification. These aren't the usual emissions from ionized hydrogen or heated dust. Instead, they flicker across the electromagnetic spectrum in jagged, unpredictable bursts, spiking at wavelengths that correspond to no known atomic transition. It's as if the nebula's core is humming a tune composed of notes we've never heard before. Break down those erratic pulses, and patterns emerge. though not the kind science expects. The energy fluctuations follow a cascading rhythm, like a Fibonacci sequence unraveling in reverse. One moment the readings show gamma rays sharp enough to pierce lead, the next they dissolve into ultra-low frequency radio waves, frequencies typically only emitted by black holes or colliding galaxies. Even stranger, these shifts aren't random. They repeat every 47 hours with near clockwork precision, as if the nebula is running on a hidden timer. Some researchers argue this could be the signature of a gravitational singularity lurking just beyond the veil, not a black hole, but something more exotic. Certain theoretical models predict the existence of naked singularities, black hole-like objects stripped of their event horizons, their chaotic cores exposed to the universe. If one sits at the nebula's heart, its extreme gravity could be twisting spacetime into a kind of cosmic whirlpool, stirring the surrounding gases into those eerie, rhythmic pulses. Imagine a stone dropped into a pond, but where the ripples reverse direction mid-spread, defying the laws of hydrodynamics. That's the level of anomaly we're dealing with. Then there's the plasma lensing theory. The doorway's pillars are laced with charged particles, their densities varying in concentric layers like the rings of an onion. When energy passes through these layers, it could be bent and filtered, creating interference patterns that mimic intelligent design. Laboratory experiments with superheated plasma have produced similar effects, self-organizing structures that resonate at multiple frequencies simultaneously. But on this scale, it's unprecedented. The pillars might not just be shaping the nebula's light, they could be orchestrating it, turning the entire structure into a natural amplifier for energies we don't yet understand. Yet the most tantalizing data comes from the void itself. Spectrographs trained on the arch's empty center occasionally catch phantom emissions, transient flashes of negative redshift. Normally, redshift tells us an object is moving away, negative values imply motion toward us, but there's nothing there to move, unless, of course, the emptiness isn't empty at all. Could these be glimpses of light bleeding through from the other side of a wormhole? It's exotic matter bending wavelengths in ways that invert physics as we know it. The math almost supports it, almost. The doorway nebula doesn't just challenge our models, it mocks them, offering just enough evidence to hint at revelation while withholding the key. Every new observation deepens the mystery, leaving us with a choice: dismiss it as a cosmic mirage, or accept that some doors exist not to be opened, but to remind us how much lies beyond our reach. Deep within the swirling heart of NGC 262, something pulses in the dark, a signal that flickers like a candle fighting a tempest. Unlike the predictable rhythms of pulsars or the steady glow of quasars, this anomaly stutters into existence without warning, broadcasting for days, sometimes weeks, before vanishing into silence for years. When it does appear, its properties defy categorization, a jagged waveform that dances across frequencies, morphing from radiostatic to gamma-ray spikes in a single breath. The first astronomers to detect it labeled it simply the flicker, a placeholder name for a phenomenon that refused to fit into any known box. What makes the flicker so unsettling is its location nestled within the galaxy's core, where supermassive black holes typically dominate the electromagnetic landscape. Yet this signal bears no resemblance to the chaotic roar of accretion disks or the predictable spin of relativistic jets. Instead, it crackles with structure, its pulses clustering in groups of 3, 5, and 7 prime numbers again, echoing the same mathematical harmony found in the singing black hole's vibrations. Is this coincidence or a fingerprint, a natural resonance of the cosmos, or something calling attention to itself? Attempts to decode the signal have led to dead ends and wild speculation. One team of researchers noticed its bursts align with the digits of pi when converted to binary, but only if you start at the 999th digit. Another pointed out that filtering the signal through harmonic algorithms produces what almost sounds like a melody, a sequence of tones that, when slowed down 1,000-fold, resemble a distorted, galactic scale version of a centuries-old Earth hymn. Skeptics dismiss these as apophenia, the human brain's tendency to find patterns in noise, but the eerie precision of those prime number clusters lingers, a riddle wrapped in cosmic static. Then there's the transmission's most baffling trait: it's getting stronger, not steadily but in jumps, as if whatever's producing it is learning to amplify its reach. Early observations required the most sensitive radio arrays to catch whispers of the flicker. Now, amateur astronomers with backyard telescopes have begun picking up its ghostly handshake. If this trend continues, within decades it might shine brighter than the galaxy's own core, a beacon impossible to ignore. Theories abound. Could this be the death throes of a magnetar, wrapped in an invisibility cloak of exotic matter? A wormhole's mouth vibrating like a plucked string as it bridges distant regions of spacetime, or whisper it, a signal not meant for us at all, but one we've stumbled upon midway through its billion-year journey to somewhere else. NGC 262 has already proven itself a gallery of cosmic contradictions, but the flicker might be its most profound lesson yet, that some mysteries don't just resist explanation, they evolve faster than our questions can chase them. And as we strain to listen, one truth becomes clear: the universe isn't just stranger than we imagine, it's stranger than we can imagine, and the flicker is its latest, most tantalizing proof. From the twisted nebula's impossible colors to the doorway nebula's silent invitation, NGC 262 isn't just a galaxy, it's a cosmic carnival of contradictions. 30 objects, each more bewildering than the last, have rewritten the rules of reality before our eyes. Think about it: a black hole that sings in golden ratios, a hollow asteroid lined with geometric tunnels, a dust cloud that learns. These aren't just anomalies, they're glimpses into a universe far stranger than textbooks dare to suggest. Together they peel back the veneer of cosmic predictability, revealing a realm where physics feels more like improvisation than law. What makes these discoveries so thrilling isn't just their individuality, it's the pattern they form when seen as a whole. The quantum crystal reef and the phantom cluster challenge our grasp of matter, the time-dilated quasar and the reverse entropy zone taunt our understanding of time. Even the seemingly mundane, like the fractured moon or the living dust cloud, insist that ordinary is a myth in this corner of space. NGC 262 isn't playing by the rules, it's scribbling new ones in the margins of reality, daring us to keep up. And that's the real magic here. Every oddity we've explored isn't just a curiosity, it's an invitation to question, to wonder, to admit how much we don't know. Maybe you're captivated by the diamond core planet's impossible glitter, or maybe the flicker's cryptic signal haunts your imagination. Whatever your favorite, one thing's certain: the universe is stranger, wilder, and more inventive than we ever dreamed. So what's next? These 30 objects are just the beginning. With every upgrade to our telescopes, every new algorithm sifting through starlight, who knows what other wonders await in NGC 262 or beyond. If this journey through cosmic weirdness has left you hungry for more, you're not alone. Drop a comment below sharing which object left you awe-struck, and don't forget to subscribe. Because the universe, it's got plenty more surprises up its sleeve, and we're just getting